Hey guys, welcome back to another video. This one's on problem 12 of the 2023 Aime 2. And the solution I wanted to share, I'm quite excited to share because I think it's by far the nicest solution I have seen to this problem. So the first part of this is to look at parallelogram PBQC. Now, because angles PBQ and PCQ are equal, along with the fact that diagonal BC is bisected by diagonal QP, we can tell that quadrilateral PBQC is in fact a parallelogram. And this means that the lengths QM and MP are also equal to each other. So I just drew that in real quick. But don't forget that a parallelogram BPCQ is in fact a parallelogram. Now, the next thing I want to do is really quickly just label the angles in triangle ABC. This is going to come in useful right in a second here. So hopefully you all know some basic properties of cyclic quadrilaterals. I'm about to use them right now. So we can start by noticing that angle BPC is in fact equal to 180 minus alpha degrees. And now because BPCQ is in fact a parallelogram, this means that angle PCQ is supplementary to 180 minus alpha, making it in fact alpha. Now, the next thing I want you to notice is that angle ABC is equal to beta degrees, and this must equal angle APC, again by cyclic quadrilateral properties, making angle APC beta degrees. Sorry. And now, this makes the third angle obviously gamma degrees, because it's just like triangle ABC when two angles were alpha and beta, the third was gamma. Now, this clearly establishes that triangle CPQ and triangle ABC are in fact similar to each other. Okay, now we've got similarity, but that doesn't really help us unless we know the ratio of similarity. So we might start by thinking we want to compare some pairs of sides in these two similar triangles, but notice that all of the sides in triangle CPQ are kind of hard to find. But we can quickly notice that the length CM is in fact the median of triangle CPQ because the lengths QM and MP are equal. Now, because CM is a median in triangle CPQ and AM is a median in triangle ABC, the same corresponding medians in fact, those medians will preserve the same ratio of similarity in their lengths as the ratio of similarity between the two triangles. So let me just quickly write that down to make it clear. So CM divided by AM actually is the ratio of similarity between those two triangles, which should be pretty clear. Now, how do we find AM? Well, finding AM isn't too bad. Let's do it over here. So AM is, I'm just going to use X for the length of AM in the calculations when I solve for it. We can solve for this pretty quickly using Stewart's. So I just wrote the equation down for X using Stewart's theorem. You can search up what that is if you're not sure about it. And if you want, there's an even more specific form of this formula just for a medians, but just knowing it for any general CVN like AM is just fine as well. And now that we have this equation for the length of AM, which we're solving for as X, you can do the arithmetic on your own. It's not too bad. You can quickly, easily find that X, the positive solution, is equal to square root 148. Now that we have that, finding the ratio between CM and AM, and consequently the two similar triangles, becomes simple. Because CM is in fact just equal to 7, because BC is 14, which is given in the problem, and CM was just half of that, because AM is a median. And the length of AM is just square root 148. And now we're really at the home stretch here because the problem is asking for the length of AQ. But AQ is just equal to AM minus MQ. But AM is just equal to square root of 148. And now MQ, let's do this really quick. So MQ is basically, it's the corresponding length in triangle CPQ as the length MC is to triangle ABC. So MQ is basically just MC, but scaled down by the ratio of similarity. So MQ is actually just that ratio of similarity times CM, which is 7, which is just basic similar triangles. Now, you can compute this subtraction. It comes out to be 99 divided by the square root of 148. Now, we basically solved for what AQ is, and the problem wants to know what M plus N is, where M and N are basically from the format of this fraction. So just 99 plus 148. Hopefully you don't mess up now. That's 247. And we're done. Hopefully you guys found that entertaining. I know this is on quite the easier side for a problem 12 in an Ame, but this is still quite an elegant solution. It uses only really basic topics, which I found really nice, and it's also one of the fastest solutions I found for this problem. Thank you.